We're going to do confidence intervals again. Yeah, yes. No big deal. I talked to Mrs. K about this thing about, it says on your sheet, the Cambridge thing about, the probability of 0.95 is 1.645. And since the dawn of statistics, it's really 1.96. I'm going to keep it as 1.96. And if you use the Cambridge one, that's fine. You just have to write Cambridge when you do it. Okay? Yes, sir.
Is this on the Z-score table?
That's correct. It's on that little table. Emily's like, oh yeah, he's going to talk about that whole thing right over there. And the reason why that comes to me, I don't know, it's just saying this to me as well. They're treating it, just cheesy here, okay, and then we'll go over this. You know, 95% is here, right? 0.95 of all the possible means that are associated there. And that's 2.5%, 2.5%. What I believe it's a one-tail test that they're doing, right? So what's that mean? So that means they include this hump, camel's hump, and they include this, and they call it 0.975, and they're saying it's rated 0.95. They're saying that that is relatively the same thing, which it isn't. And they're saying this whole thing here now is going to be, I believe, so 0.95 to them is equal to PF, right? And so the Z-score would be 1.645, right, Emily? And then 0.975 would be the Z of here of 1.96. Now, ever since the dawn of statistics and Pascal and Bayer and everyone else, the fathers of statistics, if you want to say it that way, I think that I learned 100 times. And you had Desmond, right? You guys like guys on Desmond? Desmond
Davis.
Thank you. Double D, right? And he's like, hey, I was in college, and when someone says that to me, you got my, I'm like a hawk, right? And I'm like, yeah, because I taught statistics in college. And he's like, that's what the guys use. I'm like, well, I don't know what they're doing. So what I think they're doing is called a one-tail test. Or they're doing something with the mean, the standard deviation, based upon they're saying n is, maybe they're saying n is less than 30, so then we're going to use this. Now, you can use either one. You just have to tell me on the test which one you're using, all right? But in the real world, guys, and I've done this in the real world, I told you about my General Mills thing and everything else, guess what I use for 0.95, 1 to 0.96. Okay? Yes, sir.
But where does the 0.95 come from that? Because it doesn't round up.
0.95, what do you mean, for the probability?
Yeah.
Well, the probability is 95% of possibly where the mean might show up, right? That's what it's saying. It's not all the data, it's where the mean might be. I had to say that as my disclaimer, you know? Like you buy the car and it shows like this little disclaimer. Do you ever buy something and there's like this little disclaimer and it tells you everything? Well, I have to do the same thing here. Everybody says, well, 95% of all the data's in there. Well, you guys are pretty smart, and guess what? It's going to be just 95% of the mean, possible means might be there. Yes?
Then you're going to have to prove 0.975 is equal to 0.95.
Oh, I can. I think I know what they did. I think they did a one-tail test. Now, Mrs. K said, well, just, you know, what do you want to, she said, what do you want to do, young man? I'm like, no, you're my age, you know. Okay. But I get the idea. But I told her, like, hey, it's your class, and so on. I'm a tourist. But I still, you know, I went through all my notes and everything else, even my graduate statistic notes, and I use 1.96. Okay? But if you use 1.645, just tell me that you did. You know how to calculate it like we did this one here? Okay? All right. So that's my disclaimer for the day. All right, let's talk about this stuff right here, right? We talked about yesterday what, Murmur? Well, I got to go through it, right?
Confidence interval?
Confidence intervals and everything else, right? And then I did something like this. I drew a picture. I had a whole bunch of notes on here and so on. Just to review, if you wish, because I'm going to. This is alpha over 2. This is alpha over 2 minus, yeah? And then this is minus z alpha over 2. This is positive z alpha over 2. We're just splitting up the camel's hump, right? And then this is the confidence interval. Remember, confidence interval is equal to 1 minus, CI is equal to 100%, 1 minus alpha, okay? That's a famous way to find the population of the means. Real cheesy stuff here, so we're going 0.95. And Bella's going to say, hey, there it's 0.025, right? And 0.025, am I correct? Pretty easy stuff so far? Yeah, sure. Right. So it feels like, what are you doing? 95% of the mean is going to be somewhere in here, sandwiched, okay? That means the outliers are the tails. They call those the tails. And I think you guys already knew that. All right? So we did the dog food example here for the 95% confidence interval. So what did we use? We used, remember that formula? We would set what? X bar is plus or minus what? Z. And we use two possible formulas, right? And we're going to use, I'm going to use sigma over the square root. Is it sigma over the square root n?
Yeah.
Yeah. Right? And this will give me two values because of the plus or minus.
Right.
He's on, right? So we did the dog food thing of 1.15, right? Did we do that one together? Did we finish that one?
Yeah.
And what did we get, just for fun? And then I'll do the 68% one, okay?
0.921 to 1.379.
Okay, all right. So, remember, Sammy's on the line there, and I used the Lucy metaphor or something, right, or analogy. This is what he's supposed to get, and that's what they told him by the standard of regulations of the government. You only have a fluctuation of a little bit from this meat, right? And this is what Sammy found out through his sample of 100. Now, there's thousands, it's infinite, right, Zach? So you just go there and just like grab a little bit, right? And that's what you're really doing. Now, let's say Sammy's off his shift because I don't know where he is now. Maybe he's doing double shifts, triple shifts. I don't know where he is. 4 days, so I feel weird. Okay? Then let's say one of you guys come in and fill in for him. And you do the same sample. Well, yours might be a little different here, right? But it should fall within this realm. Yeah? Because if it falls over here, which is smaller, or falls over here, then it's an outlier, right? And most likely it's defective. So by the government standards, the 95% confidence interval, they'll probably accept this. Pretty good? So if I had a value, they like to ask this on Cambridge, and I'll pass out the Cambridge stuff a little later, okay? Tomorrow. And then I got to do population means. It's almost identical, okay? And if they like to do this, well, if you had a value of 0.85, will you accept that value as the whatever it is for widgets? And the answer is no. Good. No. Why?
Because it's outside the
It's outside. Remember? You ever saw Meet the Fockers? Oh no. Oh yeah. Okay. So what's the answer? Meet the Parents? It goes Meet the Parents and then Meet the Fockers, right? And he talks about Robert De Niro, the Circle of Trust, right?
Yeah.
Okay. So you have to be in here. It's called the Circle of Trust, right? Because he caught him smoking dope or whatever it was, and it was his son instead of the son-in-law. So he construed that the son-in-law was smoking dope in his son's room, which was a lie. So that means he's outside the Circle of Trust. So therefore, 0.85 wouldn't work. Conversely, that means also what? 1.65, for an example, would not work as well. Okay? That's the logic that they're using. Pretty easy? Okay, let's keep going, right? Yeah, sure. It's my time, right? How much time we got?
We got lots of time.
Oh, awesome, awesome.
Is there more to the lesson, or is it just...
It's this, and then I want you guys to work it out, okay? So let's do a 68 CI, okay? And then I'm going to do another one over there in a second, okay? All right, 68% CI, you want to try it out? Do we all agree now? Ems, what do they have for the value or anybody? Okay, because she has. I've seen Emily most of the
29.
day, so I'm going to probably say Emily in the next class, okay? But because she has the. And what do they have for the Z-score for 68%? 1.7. Okay. All right. And what did I use? I got to find out what I use for 68%. Okay. So let's use the Cambridge of whatever it is. 0.75, 1.7. So give me the confidence interval for the same thing Sammy's talking about, for 68%, okay? All right, so here we go. Yeah, 68%. Okay.
We're doing it on our own.
On your own, yeah, I know. Get for both values, anyone, Bueller.
For the lower one, I got 1.095361.
1.095, good enough for me. And higher?
1.2046.
I put 1.2 and 1.1.
And I would live with 1 point, either, okay? I'm happy with either.
Yeah.
Okay? Not bad? Yes, sir.
Does it matter which order that you have them in?
Yes, it does. It's like low, high.
Oh,
Because
okay.
when you do that, it's a confidence interval, right? I always call that the -1.
That's how you give the answer.
Absolutely. Absolutely.
Order pair.
Yeah, order pair. Yes, order pair. Ooh, yes.
Square root.
Pardon me?
What number is in the square root?
Oh, square root of 100. I'm sorry.
And
Sophie.
the number of
The number of choices
things
here,
are- yeah.
she wasn't here, so it's 100 right there. Whatever the sample size is. If there's 1,000, 10,000, whatever. Okay. Usually when we do this, it's over 30. So we get this occurrence that happens over and over again. If it's not, then we use another sigma. All right. Not bad. 99%. What did they say for the probability of 99% is? We'll do the Z. Z is what?
2.326 on the bottom sample.
To me, it should be 2.5. But is there a 2.5 anywhere there?
Not exactly.
Is there a 90? Is there a 99.5?
Yeah.
What's a 99.5?
2.576.
That's it. All right. I will specify on the test. I will specify on the test 99.5. Okay. All right, guys. What they like to do is do this. They go 68, 95, and they like 99, but we'll say 90. It's called the rule here, okay? For the probabilities.
Okay.
All right? That's the ones that I've always been indoctrinated with, okay? And Ryan's right, okay? So if we did 68%, not to scale, it's only what? A z-score of here to here, right? And then the next one would be over here. And then 99% would be farther out. Okay? So for, let's do 99.5, and it's 2.543? Yes?
Wait, for which one?
99.5. 0.99.
576.
576. Okay, so we'll use that one, all right? I don't want to get screwed up on which one to use. Yes, sir.
So the .995, like, how does that relate to the 68% confidence interval?
Okay, 68% confidence interval is around here, right?
Uh-huh.
And then 99.5 is even farther, right? You're including more of the Campbell's zone.
But they didn't ask for that.
Yes, they did. I asked for it right here.
Oh,
It's
so you're doing part
we'll
C.
say
Okay.
99.5, okay?
I thought
They've
you were...
always used
You just didn't
99.5.
see the part.
Yeah.
You just didn't see it. That's it. Okay? I wanted to go over this, so like, oh, that's all you want? That's it? Yes.
Oh, because, so the greater the probability of the confidence interval, then it's going to be a broader, the greater the probability, the greater the difference between the low end and the high end, because mathematically that works, because if the higher probability, it's always going to be a higher z-score on the table, the way you're doing it, so that means that what you're subtracting, what you're adding is much drastically different.
Yes. It's like a canvas, right? Instead of a small canvas to paint the Mona Lisa, this is 68%. Let's say just by, because I'm, exaggerating, 99.5% is the whole, the whole board, right? And so the image is bigger. But what happens is something gets lost, right? The more I include things, the greater error I have. Well, I'll talk about that later, not now, right? Because the error can happen, right? Oh, yeah. No? Someone like this? No. Yes. No. Yes.
So a confidence interval of a smaller probability, like if it tells you a data set and says about like a 10% confidence interval, the numbers are going to be so close together, it's going to be a very fine line.
A very small,
At
yeah.
what point would it even be worth it? Because at 68%, it's 0.1.
Yeah. So it's 68% worth it, right? Yeah, exactly. You're not really including everything. Now there's more error, there's less error here, but the more you do it, there's going to be more error because there's more randomness.
Lower the confidence interval, the less room for error that you have.
Yeah. Well, I'm not, this is not Stats 500, okay? Yeah. Just make the confidence interval.
Yeah, just know how to
Yeah, just how to do it and so on, okay? All right, so how do we do this one, right? So it's going to be, again, what?
1.15.
1.15. Go ahead. Talk to me, Nick.
Plus or minus 2.576 times 1.17 over 10. Really, it's square root of 100.
Square root of
but-
100,
yeah.
we'll keep that there, okay? Close. And then values, please.
Lower is 0.8486.
848.
Higher is 1.451.
Okay? So Sammy's 99.5, right? 99.5 of the samples should be between those ranges. Yes, sir. When you scribble.
Working, when this is like used for like the food industry,
Mm-hmm.
wouldn't it be better to go with a company that uses a lower confidence interval for your own like safety?
Oh. And why do you say so?
Because the higher it is, the more problems it can have with it.
Yes, that's true.
Because like, isn't it
Less.
like that with FDA and the amount of bugs they allow? And
Yes, defective parts and whatever, yeah. So we're talking about type 1 and type 2 errors that he's associated with, which I can't go into yet. That's down the road. Yes, you're getting into it. Also, there's the confounding variable, right? Did I talk about that at all? Probably not. I don't have enough time. But the confounding variable would be something like this, okay? There was a movie called Medicine Man. I'm going to kick to it, okay? Sean Connery and Lorraine Bracco, they were in this movie and all that stuff. So they're in the Brazilian rainforest or whatever it is, and they're studying this one guy, because he's Sean Connery, of course, he has the long hair and whatever, and Lorraine Bracco's this researcher that comes with him. They're both PhDs. And he's working on a cure for cancer. He thinks he has it. And he has something that is made from sugar that's only associated with the sugar plants in Brazil. So now there's this other stress that's going on and everything else. The loggers don't want them there, right, because it's sugar cane and everything else. They want them there. And the natives don't want him there either, right? So they're both in a pickle. So what happens is they're doing this research and everything else, and all of a sudden they find out that it's not the sugar that he's been studying for 100 years. It's the ants that are eating the sugar that get mixed in the sugar.
It's about 85%.
I'll go along with that. Do it for this one as well. Now this one here, we're going to change this up a little bit, okay? This is pretty easy stuff, right? And now I have a form on that as well. I don't know how much time left. So the random variable of 50 secret shoppers, right? Spend an average, so 50 secret shoppers go into store XYZ, right? And they spend an average of $15, and there's a fluctuation of $6.5 for each one of them, right? So find the 85% confidence interval of all those shoppers. So therefore, we need a couple variables, right? We already got Z of Ryan, which is 1.036, right? Yeah, good. Now, what's N for this example here? 50 shoppers. What's the next thing we need? Little sigma. What's little sigma? 6.25. What's X bar? 15 point what?
5.
Dollars. So we're going to figure out the confidence interval of 85%, right? From here to here, and that's it. It's not tough, is it? It's not tough. Yeah, come on, man. Yes, sir.
So when would we use this other formula, like the P little...
Population, that's
Yeah.
tomorrow. I'm going to talk about that tomorrow.
And then the T, the X bar minus mu over all that
We're not
stuff.
going to do T-distribution. Unfortunately, it had those Sammy notes included, my former notes included in there. I wish I had time to do T-distribution. If we do it, then it has to do with hypothesis testing. But we'll do population, and then that'll be it for the next test. And then we'll do something where you have to figure out the T for hypothesis testing later. All right, so Z of Ryan, right? So Ryan's going to be like 85%, right? So you divide 85% divided by 2, so it's what, 47.5, right? Underneath the camel's hump? 85 divided by 2, am I right? What's half of 85? That's 42.5%, right? So it's 42.45% here, 42.5% there. Pretty straightforward. Because you're splitting this in half, right? Remember, it's going to be what? Probability is 0.85, right? So that means you're going to have a negative 1.036 for Ryan and 1.036 that Sammy must use. See, Ryan's the CEO. And he says, hey, Sam, use this. Okay? All right. Not bad. What did you get? Oh, Ryan, Mr. Tribble's working, Mr. Barden, and Sophie understands. Good. All right. Hopefully. And I do have this tomorrow. We'll go over this thing, okay? And it talks about, well, this is all the answers because I worked it out, okay? And the other one is the same thing, okay?
Lower bound.
Lower bound, I don't know what he said there. Go ahead, talk to me.
14.584.
58, $14.58, and the other guy?
Upper 16.41 or 42.
42. So, if I said, what does this mean, right? This is later on, okay? What does this mean? And Zach's going to say, we have a 85% confidence interval that the mean falls between this guy and this guy. Never ever, Zach, and all of you, at all, that means everything in Latin, never say that all the data is between this value and this value. No, it is where the mean falls.
The mean falls between the two.
The mean falls between that guy and that guy. So it's a dartboard, right? Possibly here and here, 85% hitting it. So that means the tails are 0.075, 0.75.
The mean is somewhere in that stuff.
That's what, exactly. Somewhere in that confluence, okay? Not bad? So, if you want, we'll go over this tomorrow, and then I'll give you the evil Cambridge, right? And then I'll start talking about sample populations with the P. Sometimes it's called p-hat, okay? And they do it through elections and everything else. Is that all I got? Time?
You've got a few more minutes.
Well, really? It's like don't you dare, right? Okay. So, not bad. So, we just have to agree on what Z's we're going to use, okay? Maybe for fun, I thought, like, well, I'll make them look it up. Well, Cambridge is different than the mantra that Mrs. K and myself learned, okay? Especially for 0.95. Yes, sir.
So that I can just cross out number 3 because you said we wouldn't be doing that.
The T guy?
Yeah.
Yeah, we are not going to use the T guy right here. But we will